Hello everybody, Matt Ruddick here. I'm the Multi-Rotor Associate Editor for Model Aviation magazine, and I wanted to talk to you about a new advanced flight technology that is currently rolling out across the USA and will be fully implemented by September of this year. You may have already read about it in the July 2018 issue of Model Aviation magazine. It's the Low Altitude Authorization and Notification Capability Program, or LAANC. It was developed by the FAA to provide near real-time processing of airspace authorization requests for unmanned aircraft operators nationwide. Now, many of you are familiar with the National Airspace System, or NAS, which has served the aviation community well for decades. The most visible manifestation of the NAS are sectional charts. Updated and published by the FAA every 6 months, sectional charts are maps of the airways that are designed for navigation under visual flight rules and shows useful information that's important to aviators. Most importantly to SUAS operators, sectional charts show airspace classifications, which are broken out into A, B, C, D, E, and G. An analogy frequently used to explain these classes are upside-down wedding cakes, which describe how controlled airspace expands with altitude in tiers around controlled airports. Now, these sectional charts are useful to full-scale aircraft operations, but they aren't exactly catered to SUAS pilots. For instance, at the scale of drone operations, it's very imprecise. The lines printed on these charts to distinguish between controlled and uncontrolled airspace, when superimposed on the real world, are nearly half a mile wide. Now, a Boeing 737 will cover that distance in like 3 seconds, but it could easily represent the entire area of operations for a drone pilot. Now, the second problem is that when a manned aircraft pilot wants to enter controlled airspace, the pilot makes a call to the control tower and gets an immediate answer. Before LAANC, a drone pilot who wanted to enter into the same airspace had to send an email to the FAA headquarters in Washington, D.C., and at best could expect an answer in approximately a month. Now, to help create a system that has better resolution and response time for drone pilots, the FAA began constructing what they call Uas Facility Maps, or UAS-FMs. Throughout 2017, the FAA began working with more than 500 airports across the country to conduct a detailed analysis of where drones could safely operate within controlled airspace. The FAA reasoned that just because you don't want a Cessna 172 barreling through a particular patch of sky at 120 knots unannounced, doesn't mean that a drone couldn't safely conduct a roof inspection at 75 feet above ground level in the same area, provided air traffic control were aware of it. To construct the UAS-FMs, the agency divided the area surrounding each airport into a grid of 1 mile squares and worked with local controllers and airport managers to determine how high a drone could fly within each of these squares. On the approach and departure routes, that altitude is 0. However, elsewhere within the airspace, the altitude rises to 100 feet, 200 feet, or even the 400-foot maximum established by Part 107 regulations. The altitudes indicated on the UAS-FMs do not give automatic permission for drone pilots to fly in those locations. They merely indicate where operations can occur without additional safety analysis. You still need authorization to enter that controlled airspace, just as a manned aircraft pilot does. And to facilitate this process, the FAA has partnered with the private sector to provide nearly real-time approval for these requests. Presently, 4 companies provide these services: Skyward, Rockwell Collins, Project Wing, and AirMap. Known collectively as UAS Service Suppliers, or USS, they're responsible for taking UAS-FM data and building maps for their users, incorporating additional information such as temporary flight restrictions and notices to airmen. Accessing the map provided by his or her USS, an individual pilot or commercial drone operator requests permission to fly using an interface such as a website or a smartphone app. Now, that request is then relayed through the FAA's network to the local air traffic control, which has the option to approve or deny it. The whole process has the potential to work in nearly real time, as do requests from manned aircraft. For airports not covered by UAS-FMs, pilots can still seek approval directly from the FAA. Recreational pilots under Section 336 are not required to follow LAANC at this time, but are still required to notify all airports within 5 miles of operations. The LAANC system rollout began on April 30th of this year. The South Central region was the first to go live. The Western North region was next on May 24th. The Western South region followed on June 21st, and the Eastern South region will go live July 19th, with the Eastern North region following on August 16th. Now, the Central North region will complete the process when it goes live on September the 13th. LAANC is only one project under the technology umbrella known as the Uas Data Exchange. Looking ahead, the FAA anticipates that additional initiatives will be launched using the same information infrastructure, which means that this is only the beginning of a process that will see commercial drone operators become full members of the aviation community.